The pre-war world that gave birth to RobCo Industries and General Atomics International was one defined by both unprecedented technological optimism and deep social decay, a paradoxical era where humanity's reach for convenience and efficiency accelerated its own obsolescence. Following the resource wars of the 21st century, as fossil fuels dwindled and the global economy fractured under the weight of scarcity and militarization, the United States turned inward and placed its faith in innovation rather than diplomacy. The American government, through both public programs and private contracts, began to incentivize large-scale automation to sustain a collapsing industrial base. The earliest prototypes of autonomous systems emerged from defense contracts and domestic manufacturing initiatives seeking to maintain productivity without reliance on human labor, whose costs had become politically and economically untenable. RobCo Industries, founded by the visionary entrepreneur Robert House, and General Atomics International, a major player in both energy and robotics research, became the twin pillars of this automated age. By 2040, RobCo's computer terminals had become a ubiquitous feature of American life, controlling systems in factories, schools, homes, and military installations, while General Atomics was producing increasingly sophisticated mechanical assistants capable of performing tasks once reserved for people. Automation had ceased to be a technological luxury and had instead become a national necessity, an essential pillar of survival in a nation spiraling toward economic exhaustion. RobCo's rise was fueled by Robert House's belief in logical precision and mechanical reliability over human inconsistency. He envisioned a world where the inefficiencies of labor, emotion, and human error could be removed from all major systems of governance, production, and security. This ideal aligned perfectly with government and corporate interests during a time of civil unrest and energy crises. As American cities grew unstable and industries shuttered, automation promised control, a way to keep systems running without the unpredictability of strikes, protests, or human failure. General Atomics, originally a defense contractor specializing in nuclear energy systems, saw similar opportunity in the domestic sphere. Its flagship creation, the Mr. Handy line of household robots, was marketed not only as a convenience, but as a patriotic duty, helping families maintain productivity and cleanliness for the sake of the nation's stability. Both companies profited immensely from the fear of decline. As unemployment soared and the middle class eroded, advertisements promised that machines could preserve the American dream. The result was a cultural transformation. Citizens grew dependent on robotic assistance. Terminals managed the minutiae of everyday life, and the line between human and machine responsibility blurred. Government agencies outsourced decision-making to automated systems designed by RobCo, while military units experimented with robotic combatants to offset manpower shortages. The automation boom became self-perpetuating, each success leading to greater reliance on the same technologies that were quietly eroding the need for human participation. By 2050, automated systems governed production quotas, rationing schedules, and urban security networks. The human workforce was no longer indispensable, but merely tolerated. RobCo's operating systems formed the unseen nervous system of America's infrastructure, while General Atomics provided its visible mechanical muscle. These two entities, one digital, one physical, were symbiotic yet competitive, their technologies converging to reshape every facet of civilization. Factories once filled with human laborers now hummed with the tireless precision of protectrons and utility bots. Suburban homes, powered by General Atomics' energy systems, and monitored by RobCo terminals, became microcosms of an increasingly artificial society. While the public embraced these advancements as proof of progress, the underlying motive was survival, to maintain production and order without reliance on a volatile population. Automation had become both a technological and political instrument, allowing those in power to tighten control over a society too unstable to manage itself. Yet beneath the surface of this apparent efficiency, the human cost grew invisible. Entire sectors of employment vanished. Skilled labor was replaced by machines, and the nation's economic model shifted from production by humans to consumption managed by algorithms. The middle class dissolved into dependency, their livelihoods replaced by the very inventions marketed as their salvation. The corporations at the helm, particularly RobCo and General Atomics, framed this transition as inevitable progress, a march toward an idealized future where humanity could transcend toil. But the deeper truth was that this was less evolution than displacement. By automating every system of production, defense, and domestic life, the United States rendered itself vulnerable to a paradox of abundance. The more it automated, the less it required its own citizens. The political ramifications were profound. Automation gave the federal government an unprecedented ability to maintain order without the consent or cooperation of the governed. RobCo's terminal systems were integrated into everything from law enforcement coordination to energy distribution, giving bureaucrats and military officers direct digital control over the nation's arteries. General Atomics defense models, including early prototypes of the Mr. Gutsy and SentryBot series, provided autonomous enforcement units capable of acting without hesitation or conscience. The boundary between civilian life and military oversight blurred, enforced not by soldiers but by circuits. As this technological ecosystem expanded, so did the risks of overdependence. Systemic malfunctions, data corruption, and hardware degradation began to appear with greater frequency. Yet the pace of automation left little time for oversight or ethical regulation. Each company sought to outpace the other in efficiency and innovation, often releasing experimental designs directly into the market or field without comprehensive testing. The government, desperate to maintain stability amid the global resource crisis, turned a blind eye. The result was an unregulated technological arms race that placed the future of civilization in the hands of machines whose creators barely understood their long-term implications. RobCo and General Atomics were no longer just companies. They had become institutions of survival, embedded into every structure of pre-war America. Schools taught children through RobCo terminals. Hospitals relied on automated systems for diagnostics. Even law enforcement used General Atomics prototypes for patrol and suppression. Each innovation seemed to promise salvation, while quietly removing another layer of human agency. The average citizen no longer understood how the systems around them worked, only that life without them was unthinkable. In the eyes of historians who would later piece together the fragments of this era, the dawn of automation was not merely a technological shift, but a civilizational one. America had traded its autonomy for efficiency, its humanity for order. The groundwork had been laid for a society that would one day continue to function long after its creators had vanished. The hum of machines replacing the voices of men. In the sterile glow of RobCo terminals and the gleam of General Atomics' polished steel, the seeds of the post-apocalyptic wasteland were already sown, invisible beneath the illusion of progress. General Atomics International emerged as one of the most influential technological and industrial forces in pre-war America, a company whose focus on energy production, robotics, and advanced military applications positioned it alongside RobCo Industries as a central architect of the nation's automated infrastructure, and whose rise reflected both the opportunities and insecurities of a society increasingly dependent on machines to maintain productivity and security in the face of dwindling natural resources, political instability, and escalating international tensions. Founded in the mid-21st century, General Atomics built its reputation initially through research into nuclear power, energy storage, and mechanical engineering, establishing a foundation that allowed it to expand into robotic development, weapons, systems, and automated industrial platforms, and it was during this period that the company cultivated close ties with the federal government, providing expertise, equipment, and personnel for projects designed to ensure both domestic stability and military readiness, thereby cementing its role as a strategic partner whose technological contributions were critical to the nation's functioning. The company's early efforts focused on modular robotics capable of performing heavy labor, surveillance, and tactical operations, producing machines designed to complement human efforts in factories, military installations, and urban centers, while simultaneously serving as testbeds for advanced artificial intelligence protocols that could later be deployed in more autonomous systems. And these early innovations laid the groundwork for the development of the SentryBot, the Mr. Gutsy combat model, and a series of energy-efficient robotic platforms that would become widely recognized as emblematic of the technological prowess of pre-war America. General Atomics' approach to automation was characterized by a dual emphasis on durability and adaptability, producing machines that could operate in diverse and often hostile environments, whether in industrial facilities, military complexes, or the rapidly expanding suburban landscape. And the company's engineers developed redundant control systems, self-repair protocols, and sensor arrays that allowed their creations to perform complex tasks with minimal human oversight, reflecting a philosophy that machines should act with both precision and reliability, and that human error should be mitigated through mechanical and computational superiority, a principle that informed the design of all General Atomics hardware, from utility robots to advanced security platforms. The company's collaboration with the United States military was extensive and multifaceted, encompassing research contracts, experimental deployments, and the provision of fully integrated robotic units for training, security, and combat applications, with an emphasis on creating systems capable of functioning independently in the event of human failure or attrition, and these initiatives positioned General Atomics as a critical contributor to national defense strategy, ensuring that the government's reliance on automated systems was both practical and unavoidable. As General Atomics expanded its operations, it also became involved in civilian applications, supplying robotic laborers for factories, warehouses, and service industries, while developing energy-efficient reactors and portable power units that facilitated the widespread deployment of automated systems in urban and rural areas alike, thereby increasing the reach and influence of the company's technologies across every sector of American society, and reinforcing the interdependence between human activity and mechanized infrastructure that would characterize the nation's final decades before the Great War. The company's commitment to research and development was unparalleled, with laboratories dedicated to robotics, artificial intelligence, energy management, and advanced materials science. producing innovations that not only increased efficiency but also enhanced the safety and reliability of automated systems, allowing robots to operate under extreme conditions, perform intricate tasks, and respond dynamically to unforeseen circumstances, while simultaneously collecting data to inform future designs, optimize performance, and expand the applicability of robotic technologies in both civilian and military contexts. And this iterative process ensured that General Atomics remained at the cutting edge of automation throughout the pre-war era. By the 2052, the company had begun producing more complex robotic units, including fully autonomous combat models capable of identifying targets, navigating complex terrain, and executing tactical maneuvers with minimal human direction. And these machines were integrated with advanced sensors, programmable intelligence modules, and energy-efficient propulsion systems, allowing them to operate in coordination with human forces or independently as necessary, demonstrating a level of technological sophistication that rivaled and in some cases exceeded contemporary human capability, and which further solidified General Atomics' reputation as a leader in robotics and automation. In parallel with its military and industrial work, General Atomics developed energy solutions that complemented its robotic technologies, including compact nuclear reactors, high-capacity battery systems, and energy distribution platforms capable of sustaining both civilian and defense infrastructure. And these innovations not only expanded the practical applications of automation, but also created a symbiotic relationship between robotic systems and the energy networks that powered them, ensuring that each technological advance reinforced the effectiveness and independence of the other, and establishing a model of integrated infrastructure that became a hallmark of pre-war America. Throughout its expansion, General Atomics maintained a careful balance between competition and collaboration with RobCo Industries, recognizing that while the two companies often vied for contracts, influence, and market share, their combined contributions were shaping a technological ecosystem that would define the nation's industrial and defense capabilities for decades. And the rivalry between the firms drove innovation at an accelerated pace, with each seeking to outmatch the other in reliability, capability, and efficiency, creating a technological arms race that mirrored the geopolitical tensions unfolding between global powers and further embedding automation into the fabric of American society. The company's engineers, scientists, and designers continually refined robotics to incorporate autonomous decision-making, adaptive programming, and modular architecture, allowing machines to function effectively in unpredictable scenarios, maintain operational readiness in adverse conditions, and integrate seamlessly into existing human and mechanical systems, while simultaneously producing a standardized technological language that facilitated widespread adoption, maintenance, and upgrade across multiple sectors, from municipal services to military deployments, reinforcing General Atomics' influence over the nation's infrastructure and economy. As the 2060s progressed, General Atomics' portfolio expanded to include intelligence-gathering robots, automated surveillance units, and self-sufficient maintenance platforms, each designed to reduce human intervention while maximizing operational efficiency. And these systems were deployed in cities, factories, and military installations alike, creating an environment in which human oversight was increasingly secondary to mechanical processes, and establishing a pattern of societal dependence on machines that mirrored RobCo's own influence thereby consolidating the two companies as the primary architects of the automated American landscape. A landscape in which human agency was gradually supplanted by mechanical reliability. The integration of energy management and robotics enabled General Atomics to produce autonomous systems capable of long-term operation without significant human support, ensuring that their units could maintain critical infrastructure, perform defensive operations, and support industrial productivity under conditions that would have previously required constant human attention, and in doing so, the company established a model for resilience and continuity that would endure even in the event of large-scale societal disruption, presaging the persistent operation of these machines in the post-apocalyptic wasteland, where they would continue functioning decades after human oversight had disappeared. By the late 2060s, General Atomics International had become synonymous with automated power and robotics, producing systems that were reliable, durable, and capable of performing complex tasks with minimal guidance. And the company's reputation as an indispensable technological partner to both government and industry was firmly established, solidifying its position alongside RobCo Industries as one of the primary drivers of pre-war American automation, and ensuring that the infrastructure, methodologies, and machines it created would survive into the post-war era as both a testament to human ingenuity and a warning of the dependence on machines that would ultimately outlast their creators, shaping the trajectory of civilization in ways that neither the engineers nor the executives of the time could have fully anticipated. As the nation's reliance on automated systems became irreversible, creating a society in which efficiency, precision, and mechanical oversight replaced human judgment and agency at every level of daily life, setting the stage for the eventual consequences that would unfold when those systems would operate in a world devoid of their human architects. General Atomics International emerged as one of the most influential technological and industrial forces in pre-war America. A company whose focus on energy production, robotics, and advanced military applications positioned it alongside RobCo Industries as a central architect of the nation's automated infrastructure, and whose rise reflected both the opportunities and insecurities of a society increasingly dependent on machines to maintain productivity and security in the face of dwindling natural resources, political instability, and escalating international tensions. Founded in the mid-21st century, General Atomics built its reputation initially through research into nuclear power, energy storage, and mechanical engineering, establishing a foundation that allowed it to expand into robotic development, weapons, systems, and automated industrial platforms. And it was during this period that the company cultivated close ties with the federal government, providing expertise, equipment, and personnel for projects designed to ensure both domestic stability and military readiness, thereby cementing its role as a strategic partner whose technological contributions were critical to the nation's functioning. The company's early efforts focused on modular robotics capable of performing heavy labor, surveillance, and tactical operations, producing machines designed to complement human efforts in factories, military installations, and urban centers, while simultaneously serving as testbeds for advanced artificial intelligence protocols that could later be deployed in more autonomous systems. And these early innovations laid the groundwork for the development of the SentryBot, the Mr. Gutsy combat model, and a series of energy-efficient robotic platforms that would become widely recognized as emblematic of the technological prowess of pre-war America. General Atomics' approach to automation was characterized by a dual emphasis on durability and adaptability, producing machines that could operate in diverse and often hostile environments, whether in industrial facilities, military complexes, or the rapidly expanding suburban landscape. And the company's engineers developed redundant control systems, self-repair protocols, and sensor arrays that allowed their creations to perform complex tasks with minimal human oversight, reflecting a philosophy that machines should act with both precision and reliability, and that human error should be mitigated through mechanical and computational superiority, a principle that informed the design of all General Atomics hardware, from utility robots to advanced security platforms. The company's collaboration with the United States military was extensive and multifaceted, encompassing research contracts, experimental deployments, and the provision of fully integrated robotic units for training, security, and combat applications, with an emphasis on creating systems capable of functioning independently in the event of human failure or attrition, and these initiatives positioned General Atomics as a critical contributor to national defense strategy, ensuring that the government's reliance on automated systems was both practical and unavoidable. As General Atomics expanded its operations, it also became involved in civilian applications, supplying robotic laborers for factories, warehouses, and service industries, while developing energy-efficient reactors and portable power units that facilitated the widespread deployment of automated systems in urban and rural areas alike, thereby increasing the reach and influence of the company's technologies across every sector of American society, and reinforcing the interdependence between human activity and mechanized infrastructure that would characterize the nation's final decades before the Great War. The company's commitment to research and development was unparalleled, with laboratories dedicated to robotics, artificial intelligence, energy management, and advanced materials science, producing innovations that not only increased efficiency but also enhanced the safety and reliability of automated systems, allowing robots to operate under extreme conditions, perform intricate tasks, and respond dynamically to unforeseen circumstances, while simultaneously collecting data to inform future designs, optimize performance, and expand the applicability of robotic technologies in both civilian and military contexts. And this iterative process ensured that General Atomics remained at the cutting edge of automation throughout the pre-war era. By the 2052, the company had begun producing more complex robotic units, including fully autonomous combat models capable of identifying targets, navigating complex terrain, and executing tactical maneuvers with minimal human direction. And these machines were integrated with advanced sensors, programmable intelligence modules, and energy-efficient propulsion systems, allowing them to operate in coordination with human forces or independently as necessary, demonstrating a level of technological sophistication that rivaled and in some cases exceeded contemporary human capability, and which further solidified General Atomics' reputation as a leader in robotics and automation. In parallel with its military and industrial work, General Atomics developed energy solutions that complemented its robotic technologies, including compact nuclear reactors, high-capacity battery systems, and energy distribution platforms capable of sustaining both civilian and defense infrastructure. And these innovations not only expanded the practical applications of automation, but also created a symbiotic relationship between robotic systems and the energy networks that powered them, ensuring that each technological advance reinforced the effectiveness and independence of the other, and establishing a model of integrated infrastructure that became a hallmark of pre-war America. Throughout its expansion, General Atomics maintained a careful balance between competition and collaboration with RobCo Industries, recognizing that while the two companies often vied for contracts, influence, and market share, their combined contributions were shaping a technological ecosystem that would define the nation's industrial and defense capabilities for decades, and the rivalry between the firms drove innovation at an accelerated pace, with each seeking to outmatch the other in reliability, capability, and efficiency, creating a technological arms race that mirrored the geopolitical tensions unfolding between global powers and further embedding automation into the fabric of American society. The company's engineers, scientists, and designers continually refined robotics to incorporate autonomous decision-making, adaptive programming, and modular architecture, allowing machines to function effectively in unpredictable scenarios, maintain operational readiness in adverse conditions, and integrate seamlessly into existing human and mechanical systems, while simultaneously producing a standardized technological language that facilitated widespread adoption, maintenance, and upgrade across multiple sectors, from municipal services to military deployments, reinforcing General Atomics' influence over the nation's infrastructure and economy. As the 2060 seconds progressed, General Atomics' portfolio expanded to include intelligence-gathering robots, automated surveillance units, and self-sufficient maintenance platforms, each designed to reduce human intervention while maximizing operational efficiency. And these systems were deployed in cities, factories, and military installations alike, creating an environment in which human oversight was increasingly secondary to mechanical processes, and establishing a pattern of societal dependence on machines that mirrored RobCo's own influence, thereby consolidating the two companies as the primary architects of the automated American landscape. A landscape in which human agency was gradually supplanted by mechanical reliability. The integration of energy management and robotics enabled General Atomics to produce autonomous systems capable of long-term operation without significant human support, ensuring that their units could maintain critical infrastructure, perform defensive operations, and support industrial productivity under conditions that would have previously required constant human attention. And in doing so, the company established a model for resilience and continuity that would endure even in the event of large-scale societal disruption, presaging the persistent operation of these machines in the post-apocalyptic wasteland, where they would continue functioning decades after human oversight had disappeared. By the late 2060 seconds, General Atomics International had become synonymous with automated power and robotics, producing systems that were reliable, durable, and capable of performing complex tasks with minimal guidance. And the company's reputation as an indispensable technological partner to both government and industry was firmly established, solidifying its position alongside RobCo Industries as one of the primary drivers of pre-war American automation, and ensuring that the infrastructure, methodologies, and machines it created would survive into the post-war era as both a testament to human ingenuity and a warning of the dependence on machines that would ultimately outlast their creators, shaping the trajectory of civilization in ways that neither the engineers nor the executives of the time could have fully anticipated. as the nation's reliance on automated systems became irreversible, creating a society in which efficiency, precision, and mechanical oversight replaced human judgment and agency at every level of daily life, setting the stage for the eventual consequences that would unfold when those systems would operate in a world devoid of their human architects. The consumer revolution, driven by RobCo Industries and General Atomics International, represented a transformative period in pre-war American society, a time when the widespread adoption of automated products and systems fundamentally reshaped daily life, labor practices, domestic routines, and economic structures, creating a culture in which mechanized assistance was no longer an optional convenience, but a central component of modern existence, and establishing patterns of dependence that would persist through the Great War and into the post-apocalyptic landscape. This era, spanning the 2050 seconds and 2060 seconds, was characterized by the mass deployment of robotic platforms, service machines, and control terminals across homes, offices, factories, and public institutions, with RobCo's computational and software expertise complementing General Atomics' mechanical engineering to produce devices that were reliable, multifunctional, and capable of operating with minimal human supervision, thereby redefining the relationship between citizens and the technologies that governed their environment. Household robotics, including the Mr. Handy series and early domestic service robots, became increasingly common, providing assistance with cleaning, cooking, maintenance, and communication, and were integrated with RobCo terminals that allowed users to schedule tasks, monitor performance, and coordinate with other automated systems within the home or workplace, effectively creating an interconnected domestic ecosystem in which human labor was largely replaced by programmable, autonomous machines, and citizens came to rely on these systems not only for convenience, but for the basic functioning of their daily lives. Industrial automation also expanded rapidly, with factories, warehouses, and distribution centers adopting Protectron units, assembly line robots, and automated quality control platforms designed to increase efficiency, reduce human error, and maintain productivity. Despite workforce shortages or labor unrest, and General Atomics' contributions in mechanical durability, energy management, and mobility ensured that these systems could operate under continuous load for extended periods without significant intervention, thereby reinforcing the company's centrality to pre-war economic stability and industrial output. The proliferation of terminal systems in offices, government buildings, and commercial spaces further augmented the consumer revolution, as RobCo's software allowed for real-time data processing, resource allocation, and communication across multiple sectors, streamlining operations that had previously required significant human oversight, and creating an environment in which decision-making increasingly relied on machine-assisted logic rather than human judgment, a shift that not only increased efficiency but also subtly altered societal perceptions of authority, control, and reliability, as machines became trusted arbiters of productivity, security, and organization. In addition to domestic and industrial applications, automated delivery, logistics, and maintenance systems transformed public infrastructure, with robots and terminals managing transportation hubs, energy grids, and communication networks, enabling cities to expand and function more effectively despite the growing pressures of urbanization, population growth, and resource scarcity, and creating a sense of seamless efficiency that masked the growing dependency on a technological framework maintained by a small number of powerful corporations. The consumer revolution also facilitated the integration of advanced robotics into education and healthcare, with classrooms increasingly relying on terminal-based instruction and automated laboratories for experiments, while hospitals and clinics adopted diagnostic robots, maintenance systems, and supply management platforms, ensuring operational continuity and allowing human personnel to focus on oversight and specialized tasks, further demonstrating the ability of RobCo and General Atomics systems to permeate every aspect of societal functioning, from basic survival to specialized professional work, and establishing a precedent for widespread trust in automated processes. Marketing campaigns, advertisements, and corporate messaging played a critical role in shaping public perception during this period, framing automation as both a patriotic duty and a symbol of modernity, emphasizing the reliability, efficiency, and sophistication of robotic systems while downplaying the displacement of human labor or the growing dependence on machines, and reinforcing the cultural association of technological adoption with progress, security, and prosperity, which in turn accelerated consumer acceptance and adoption of the products produced by RobCo and General Atomics. The integration of automation into everyday life created profound economic and social changes, as traditional employment in manufacturing, domestic service, and logistics was increasingly supplanted by machines, leading to shifts in labor markets, skill requirements, and societal roles. And while some sectors adapted by retraining personnel for oversight, maintenance, or technical programming, the overall effect was a reduction in direct human participation in the processes that sustained the economy, contributing to an emergent reliance on corporate-managed automation networks that centralized control, reduced operational variability, and increased the resilience of critical systems to human error or disruption. Energy management innovations were essential to the consumer revolution, with General Atomics' compact nuclear reactors, battery storage systems, and power distribution platforms, enabling widespread deployment of automated devices in homes, businesses, and public facilities, while RobCo terminals coordinated the flow of energy, optimized usage patterns, and monitored system performance, ensuring that the interconnected networks of machines could function efficiently, reliably, and autonomously, and allowing citizens and institutions to depend on a level of technological support that had previously been impossible without extensive human labor. The scale of this transformation was unprecedented, as automated systems became ubiquitous in both urban and suburban environments, from private residences to municipal infrastructure, with robots performing tasks ranging from maintenance, sanitation, and security to complex logistical coordination, demonstrating the effectiveness of combining RobCo's computational intelligence with General Atomics' mechanical engineering in creating self-sufficient, multifunctional systems capable of operating independently, yet in harmony with broader networks, thereby shaping the functional and social dynamics of pre-war communities. The consumer revolution also accelerated research and development within both companies, as feedback from domestic, industrial, and governmental users informed iterative improvements in hardware, software, and interface design, producing successive generations of robots and terminals that were faster, more reliable, and more capable, and reinforcing the competitive and collaborative dynamic between RobCo and General Atomics, ensuring that innovation continued at a pace sufficient to meet the demands of a technologically dependent society. and cementing both corporations as indispensable elements of American infrastructure and daily life. As reliance on automation expanded, the social consequences of these technological advances became increasingly evident, with citizens growing accustomed to machine-mediated control over scheduling, production, and maintenance, while human labor became more specialized, intermittent, and supervisory in nature, and traditional social hierarchies shifted as those who managed, maintained, or programmed machines acquired disproportionate influence over the functioning of society, reinforcing the company's centrality in both economic and cultural terms. By the mid-2060s, the consumer revolution had established a society in which daily life, industry, and public infrastructure were heavily dependent on the integration of RobCo and General Atomics technologies, creating a network of interconnected machines and terminals whose reliability and efficiency enabled continuous operation across a wide array of environments and establishing a structural dependency that would have profound implications in the event of national crisis. As the survival of economic, industrial, and civic systems became inseparable from the continued operation of automated networks, the widespread deployment of automated systems also contributed to the standardization of operations, practices, and societal expectations. As citizens, workers, and government personnel adapted their routines, workflows, and behaviors to align with the capabilities and limitations of robotic systems, reinforcing both corporate influence and technological authority, and embedding automation into the fabric of daily life to a degree that human labor and oversight were increasingly supplementary rather than primary. This period of mass adoption and integration of automated technologies, often described as the consumer revolution, ultimately demonstrated the profound capacity of RobCo Industries and General Atomics International to shape society, economy, and infrastructure through the systematic deployment of robots, terminals, and energy management systems, producing a nation in which human activity was increasingly mediated, coordinated, and supplemented by machines, and establishing patterns of dependence, efficiency, and control that would endure beyond the collapse of pre-war civilization, leaving a technological legacy that would continue to define and structure the post-apocalyptic world as surviving machines maintained, monitored, and enforced the infrastructures and routines created by their creators long after humanity's direct influence had ended. The era of corporate wars and espionage between RobCo Industries and General Atomics International represented a critical, if often concealed, dimension of the pre-war technological landscape, a period in which both companies, already dominant in automation, robotics, and energy systems, engaged in strategic competition, covert intelligence gathering, and industrial sabotage to protect proprietary technologies, secure government contracts, and maintain or expand market dominance. And in doing so, they created a high-stakes environment in which the development, deployment, and control of automated systems became inseparable from corporate power and national strategic priorities. This period, spanning the mid-2050s through the 2060s, was defined by the complex interplay of innovation, secrecy, and competitive maneuvering as each company sought to anticipate and counter the other's technological advances, secure critical patents, and influence government policy to favor their respective solutions, and the result was an unprecedented acceleration in the sophistication, reliability, and scope of automated systems deployed across civilian, industrial, and military sectors. Industrial espionage was a particularly pervasive aspect of this era, with both RobCo and General Atomics employing highly trained operatives, corporate intelligence divisions, and technical reconnaissance teams to gain insights into proprietary designs, software protocols, mechanical schematics, and experimental technologies, often relying on surreptitious observation, infiltration of research facilities, and the recruitment of specialized engineers to acquire knowledge that could be used to refine existing products, preempt competitor developments, or accelerate the creation of new systems, all while maintaining plausible deniability and adhering to legal and contractual frameworks that were often deliberately ambiguous. The stakes for such espionage were considerable, as the acquisition of a single technological insight, such as a more efficient AI control algorithm, a novel robotic chassis design, or an energy optimization protocol, could translate into a decisive advantage in securing lucrative government contracts, achieving market dominance, and influencing the trajectory of pre-war automation, and both companies invested heavily in counterintelligence measures to protect sensitive intellectual property, including physical security systems, encrypted communications, employee vetting procedures, and internal monitoring networks, reflecting a corporate culture in which secrecy, surveillance, and information control were essential to operational success. Alongside espionage, both companies engaged in more overt forms of corporate competition, including aggressive patent litigation, strategic mergers or acquisitions of smaller technology firms, and targeted recruitment of engineering talent, each of which served to consolidate expertise, expand capabilities, and limit competitor influence. And these practices not only enhanced technical development, but also ensured that RobCo and General Atomics maintained dominant positions across multiple sectors, effectively controlling the direction of automation, robotics, and energy technology in pre-war America. The competition extended to military applications as well, with both companies vying to supply the United States Armed Forces with advanced automated systems, from Protectrons and Mr. Handy units to Sentrybots and autonomous reconnaissance platforms, and the result was an ongoing cycle of innovation, testing, and incremental improvement, in which each firm sought to demonstrate superior reliability, functionality, and operational flexibility, thereby securing larger and more influential contracts, enhancing prestige, and reinforcing strategic importance within the national defense framework. Covert sabotage and counterintelligence operations were also reported, as both companies sought to disrupt competitor production lines, compromise experimental prototypes, or introduce vulnerabilities into rival systems, sometimes through clandestine technical interventions or the subtle manipulation of supply chains, while carefully avoiding exposure that could provoke legal consequences, public backlash, or government scrutiny, demonstrating the lengths to which corporate actors were willing to go in order to protect competitive advantages in an increasingly high-stakes technological environment. The intensity of corporate rivalry fostered a climate in which rapid iteration, secrecy, and technical superiority became paramount, and the company's internal research and development teams were often compartmentalized to minimize the risk of information leaks, with engineers, programmers, and designers aware only of the aspects of a project relevant to their work, thereby reducing the probability that sensitive information could be exploited by rival firms or inadvertently disclosed to external parties. Intellectual property and patent control were central to this struggle, as both RobCo and General Atomics amassed extensive portfolios covering robotic hardware, software protocols, AI algorithms, energy management systems, and integrated automation networks, allowing them to assert legal authority over innovations, restrict competitor activity, and dictate the terms under which technologies could be utilized, licensed, or modified, and the enforcement of these patents often involved litigation, regulatory lobbying, and the strategic negotiation of government contracts, all of which contributed to the perception that technological dominance was inseparable from corporate influence, control, and strategic foresight. In addition to legal and covert measures, the companies frequently engaged in direct technological competition by developing similar or competing products in parallel, such as parallel AI control systems, robotic chassis designs, and automated energy platforms, each iteration seeking to outperform the other in reliability, efficiency, and adaptability. And these efforts drove rapid innovation, producing machines capable of operating in increasingly complex and demanding environments, while simultaneously raising the bar for expectations across civilian, industrial, and military applications. The corporate arms race extended into employee recruitment and retention as both companies sought to attract top-tier engineers, software developers, and technical specialists, offering incentives, resources, and access to cutting-edge facilities, and in some cases engaging in practices designed to limit competitor access to talent, such as exclusive employment agreements, non-compete clauses, and targeted recruitment campaigns, thereby ensuring that technical knowledge, expertise, and innovation remained under the control of the sponsoring corporation and contributed directly to their strategic objectives. Government involvement amplified the intensity of corporate rivalry as RobCo and General Atomics competed for federally funded projects, military contracts, and regulatory favor, leveraging their technological superiority, research achievements, and operational reliability to secure advantageous positions and, in some instances, influencing policy decisions, testing protocols, and procurement processes in ways that reinforced their dominance, further embedding automation and robotic systems into the infrastructure, defense, and economy of pre-war America and consolidating corporate influence over critical aspects of national function. The era of corporate wars and espionage also accelerated technological integration, as both companies pushed the limits of AI, robotics, and energy systems in order to outpace the other, producing increasingly sophisticated machines capable of autonomous decision-making, adaptive responses, and long-term operational continuity. And these advancements reinforced societal reliance on automated systems, as humans became increasingly dependent on the combined output of RobCo and General Atomics to sustain industrial productivity, energy distribution, civil order, and military readiness. Despite the competitive tensions, moments of cooperation and mutual benefit occasionally emerged, particularly when projects aligned with government objectives or national strategic priorities, and these collaborations allowed for the integration of complementary technologies, refinement of shared standards, and coordination of large-scale deployments, demonstrating that even within an environment defined by rivalry, both companies recognized the strategic advantages of selective cooperation when outcomes favored technological advancement and operational reliability. By the late 2060s, the combined effects of corporate rivalry, espionage, and selective collaboration had produced a technological landscape in which RobCo and General Atomics controlled the majority of advanced automated systems deployed in civilian, industrial, and military environments, establishing a near monopoly over the design, production, and integration of robots, terminals, and energy management platforms, and ensuring that the trajectory of pre-war automation, as well as the nation's dependence on it, was overwhelmingly influenced by the outcomes of corporate competition. The consequences of these corporate wars and espionage extended beyond immediate technological superiority, shaping economic structures, social behaviors, and institutional dependencies as humans increasingly relied on machines whose development, maintenance, and operational parameters were determined by the strategic priorities of the corporations rather than by conventional societal needs, and embedding a structural reliance on automation that would persist through the collapse of civilization. Leaving machines to operate independently of human oversight in the post-apocalyptic world, where the legacy of corporate rivalry, secrecy, and technological ambition would continue to influence the operation of surviving infrastructure, factions, and communities long after their creators had vanished. Ultimately, the era of corporate wars and espionage underscored the interdependence of technological innovation, corporate power, and national strategy in pre-war America, demonstrating that the development and deployment of automation was not merely a commercial or scientific endeavor, but a fundamental determinant of societal stability, economic functionality, and military preparedness, and confirming that the strategies, rivalries, and covert actions of RobCo Industries and General Atomics International were inseparable from the technological, social, and political foundations of the nation in the decades leading up to the Great War. The military-industrial nexus formed by the collaboration and competition between RobCo Industries and General Atomics International represented one of the defining features of pre-war American technological and strategic development, a complex ecosystem in which corporate innovation, government policy, and military necessity converged to create a society increasingly reliant on automated systems, integrated networks, and robotic platforms, and wherein the advancement of military technology was inseparable from the expansion of industrial automation, energy management, and computational infrastructure. This nexus emerged as both companies leveraged their respective expertise to secure extensive government contracts, provide solutions for defense readiness, and implement large-scale automation initiatives across industrial and urban centers, resulting in the development of a tightly coupled relationship between private technological innovation and national security strategy, with each reinforcing the other and creating a feedback loop in which military requirements accelerated corporate innovation, while corporate capabilities expanded the operational potential of military forces. RobCo Industries contributed to this nexus primarily through the development of advanced computational systems, terminal networks, and artificial intelligence frameworks, which allowed military planners to monitor logistics, coordinate troop movements, manage resource allocation, and integrate robotic support units into existing operational structures, while General Atomics International provided the mechanical and energy infrastructure necessary for these systems to function at scale, including autonomous combat units such as sentry bots, Mr. Gutsy models, and support robots capable of performing reconnaissance, repair, and logistical functions in both domestic and overseas theaters. The integration of automated systems into military operations extended to urban security, border, control, and industrial protection, with RobCo terminals providing command and control capabilities that coordinated the actions of robotic units in real time, while General Atomics hardware ensured durability, mobility, and energy autonomy, allowing machines to operate in diverse and often hostile environments, and creating a layered network of surveillance, enforcement, and logistical support that reduced the dependence on human soldiers for routine, repetitive, or high-risk tasks, and allowed military planners to deploy personnel more strategically in critical operations. Energy infrastructure was a critical component of the military-industrial nexus, as both companies developed and deployed compact nuclear reactors, high-capacity battery systems, and energy-efficient propulsion technologies capable of sustaining continuous robotic operations, enabling forward-deployed units, urban security robots, and automated production lines to function without interruption, and ensuring that energy availability would not constrain military operations, industrial output, or public infrastructure, while also integrating seamlessly with RobCo terminal systems to allow real-time monitoring, predictive maintenance, and adaptive resource allocation. The Nexus also encompassed research and development initiatives, in which both companies were contracted to design and prototype experimental technologies for military use, including autonomous combat drones, remote-controlled defense systems, and advanced sensor platforms capable of detecting and neutralizing threats with minimal human intervention, with both RobCo and General Atomics applying lessons learned from civilian applications to enhance military capabilities, and vice versa, producing a continuous cycle of innovation, in which improvements in one domain informed and accelerated advancements in the other. Industrial automation within the military-industrial nexus extended beyond direct combat applications, encompassing munitions production, supply chain management, and logistical coordination, where robotic systems designed and manufactured by General Atomics, controlled by RobCo terminal networks, were capable of performing tasks ranging from assembly, inspection, and maintenance to transportation, storage, and inventory tracking, effectively creating a semi-autonomous industrial environment that could sustain extended operations under conditions that would have otherwise required significant human oversight, and reducing both cost and operational risk for military and government agencies. The interplay of competition and collaboration between the two corporations continued to shape the development of military technologies, as each sought to secure proprietary advantages while also contributing to integrated systems that were interoperable, reliable, and strategically effective, with engineers, programmers, and designers from both firms often collaborating under government oversight to ensure that combined solutions met operational specifications and that new systems could be deployed seamlessly across existing infrastructure, providing the armed forces with technologically superior capabilities. Covert and strategic considerations were also integral to the Nexus, as both RobCo and General Atomics were aware that the security of automated systems, the protection of proprietary technology, and the prevention of espionage or sabotage were critical to maintaining operational superiority, and internal measures, including compartmentalization of projects, encrypted communication channels, and rigorous security protocols, were employed to protect sensitive data and prevent the unauthorized replication or exploitation of advanced military technologies. The Nexus also facilitated the development of standardized protocols for command, control, and communication between robotic units and human operators, allowing for centralized oversight of distributed systems, real-time coordination of operations across multiple theaters, and integration of automated intelligence into decision-making processes, ensuring that robotic platforms could act in concert with human-directed objectives while retaining sufficient autonomy to respond adaptively to dynamic conditions, and establishing a framework for the large-scale deployment of integrated military automation that would define pre-war operational doctrine. Training and human-machine interface were additional components of the Nexus, as military personnel were instructed in the management, programming, and coordination of robotic systems, with emphasis on understanding the limitations, capabilities, and operational parameters of automated units, while corporate engineers provided guidance, software updates, and maintenance protocols, ensuring that both the human operators and machines could perform in a synchronized manner, and that operational readiness could be maintained even in environments characterized by high risk, resource scarcity, or unpredictable variables. The economic dimension of the Nexus was equally significant, as government contracts, production incentives, and procurement policies ensured that both companies had sustained funding, access to research facilities, and direct influence over the deployment of technologies critical to national security, and the resulting concentration of technological, financial, and operational power reinforced corporate authority, ensuring that RobCo and General Atomics were indispensable to the functioning of the military-industrial apparatus, and that the development of automation, robotics, and energy systems remained closely tied to strategic objectives rather than independent commercial interest. Civilian infrastructure was not exempt from the influence of the military-industrial nexus, as lessons learned, technologies developed, and systems deployed for defense purposes often migrated into industrial, municipal, and residential applications, enabling broader societal adoption of automated systems, reinforcing dependence on RobCo and General Atomics technologies, and creating a civilian environment in which the same machines capable of tactical operations also maintained urban utilities, industrial production, and domestic routines, further blurring the lines between military and civilian domains and consolidating corporate influence across all facets of society. By the 2062, the military-industrial nexus had produced a highly integrated ecosystem in which automation, robotics, and energy management were central to both operational efficiency and strategic security, with RobCo and General Atomics positioned as primary architects of the technological landscape, responsible for the creation, deployment, and maintenance of systems that underpinned the economy, defended critical infrastructure, and enabled national military readiness, and their combined influence ensured that technological dependence, operational reliability, and corporate oversight were deeply embedded into pre-war American society. The Nexus not only advanced the sophistication of military robotics and energy systems, but also reinforced patterns of societal reliance on automated technologies, as citizens, institutions, and government agencies increasingly depended on machines for productivity, defense, and continuity of essential services, establishing structural dependencies that would persist even in the event of catastrophic disruption, and ensuring that the technological legacy of RobCo Industries and General Atomics International would endure long after the collapse of centralized human governance in the post-apocalyptic era. Ultimately, the military-industrial nexus exemplified the intersection of corporate innovation, governmental authority, and societal dependence, demonstrating that the pre-war United States had become a nation in which the development, deployment, and management of automation were inseparable from strategic security, economic stability, and social order, and that the work of RobCo and General Atomics within this nexus not only defined the operational capabilities of the military and industrial sectors, but also shaped the everyday lives of citizens, the structure of urban and industrial environments, and the long-term trajectory of civilization in the decades leading up to the Great War. Towards the second half of the 21st century, the world witnessed the proliferation of robotic platforms, such as Mr. Handy units, Protectrons, Assaultrons, and Mr. Gutsy combat models into every sector of society, from domestic households to industrial factories and military installations, creating unprecedented convenience and operational efficiency, while simultaneously displacing millions of human workers from traditional roles, generating public concern, labor disputes, and ethical discourse regarding the proper balance between human labor and mechanized assistance. Labor unions, worker advocacy groups, and social commentators increasingly highlighted the risks associated with over-reliance on automation, emphasizing that while machines could maintain continuous operation, perform repetitive or hazardous tasks, and optimize production processes, they also removed the human element from essential social functions, eroding skills, reducing employment opportunities, and concentrating economic power in the hands of corporations that controlled both the design and operation of automated systems. And these debates were amplified by media reports, government hearings, and public forums that questioned the long-term consequences of allowing machines to perform roles once central to human identity and economic participation. Ethical concerns extended beyond employment, as citizens, engineers, and policymakers debated the implications of autonomous decision-making in robotics, particularly in the context of military applications and public safety, where sentry bots, assaultrons, and other self-directed units were capable of using lethal force without direct human oversight, raising questions about accountability, proportionality, and the limits of technological authority, and prompting some government and civilian voices to advocate for regulatory frameworks, monitoring protocols, and operational restrictions to prevent machines from acting independently in ways that could endanger human life or societal stability. The displacement of labor by automation also had broader social consequences, as households increasingly relied on Mr. Handy units and domestic robots for cleaning, cooking, and maintenance, reducing the need for human domestic labor and subtly reshaping family structures, gender roles, and community interactions, while industrial reliance on protectrons, assembly line robots, and automated logistical systems shifted the workforce towards supervisory, technical, and programming positions, creating a division between skilled human operators who managed machines and the general population whose traditional labor roles had been supplanted, reinforcing socio-economic stratification and raising ethical questions about access to education, employment, and upward mobility in a society dominated by mechanized systems. Public sentiment toward automation was further complicated by the simultaneous perception of convenience, safety, and national prestige associated with robotic adoption, as citizens recognized that machines enhanced productivity, reduced the risk of injury in hazardous work, and supported the operational capacity of both civilian infrastructure and military installations. creating a paradox in which society both benefited from and depended upon technology that simultaneously undermined traditional human roles and decision-making authority, and in which the very systems that promised progress also threatened autonomy, social cohesion, and human dignity. Corporate messaging and marketing campaigns played a crucial role in framing the ethical debate, as RobCo and General Atomics emphasized the benefits of mechanization, including efficiency, reliability, and the alleviation of menial labor, while downplaying the social and economic disruptions caused by widespread automation, portraying the adoption of robotic systems as both modern and patriotic, and reinforcing the narrative that technological progress was inherently positive and necessary for national competitiveness, energy security, and defense readiness, further entrenching the company's influence over societal values and public perception, and limiting critical discussion of the consequences of over-reliance on automation. In parallel, government agencies, military planners, and policy advisors grappled with the ethical implications of automation in national defense, recognizing that the deployment of autonomous combat units such as sentry bots and Mr. Gutsy models enhanced force projection, operational efficiency, and strategic flexibility, while simultaneously raising concerns about accountability for lethal decisions, potential malfunctions, and the erosion of human judgment in critical military operations, prompting some internal debates about safeguards, hierarchical oversight, and contingency planning. Although these measures were often subordinated to the perceived imperative of maintaining technological superiority and operational readiness in the context of global geopolitical tensions, particularly the intensifying US-China arms race. In industrial and energy sectors, ethical debates focused on the delegation of control to automated reactors, energy distribution networks, and self-maintaining infrastructure, with engineers, corporate executives, and policymakers acknowledging that the benefits of operational efficiency and reliability were counterbalanced by the risk of systemic failure in the absence of human oversight, as reliance on automated systems created vulnerabilities in both supply chains and critical infrastructure that could not be mitigated without extensive monitoring, redundancy, and technical expertise, thereby linking technological progress with potential societal fragility and raising questions about the moral responsibility of corporations in safeguarding human welfare. Academia, think tanks, and professional societies contributed to the discourse by publishing studies, hosting symposiums, and issuing position papers on the ethical implications of automation, emphasizing that while mechanization offered quantifiable advantages in labor productivity, resource management, and operational continuity, it also demanded consideration of human values, social justice, and the preservation of cultural and professional knowledge, and advocating for frameworks that balanced innovation with accountability, transparency, and social welfare. Although these recommendations were often challenged by corporate and governmental priorities focused on efficiency, competitive advantage, and military preparedness, technological determinism became a recurring theme in ethical debates, as the increasing sophistication, autonomy, and ubiquity of robotic systems suggested that human society was gradually ceding control over essential functions to machines whose operation, maintenance, and decision-making frameworks were proprietary, standardized, and largely invisible to the general public, creating a structural dependence in which social and economic stability relied upon systems designed, produced, and managed by RobCo and General Atomics, raising profound questions about consent, control, and the long-term consequences of entrusting human welfare to autonomous technologies. Ethical concerns also emerged regarding the transparency, accountability, and predictability of artificial intelligence in robotics, as decision-making algorithms embedded in both civilian and military platforms were often proprietary, complex, and inaccessible to operators or regulatory bodies, creating scenarios in which robotic actions could not be easily explained, justified, or corrected, and producing both practical and philosophical dilemmas about the extent to which society should allow machines to act independently of human, moral, and legal frameworks, and the degree to which corporations bore responsibility for outcomes in cases of malfunction, misuse, or unforeseen consequences. Public backlash, labor strikes, and policy debates occasionally manifested in resistance to automation, calls for regulation, and demands for ethical oversight. Yet these movements were often constrained by the entrenched benefits of mechanization, the economic power of RobCo and General Atomics, and the strategic imperatives of a nation increasingly dependent on technology for defense, energy security, and industrial productivity, demonstrating the difficulty of challenging the trajectory of automation once widespread adoption had occurred, and foreshadowing the eventual societal vulnerability that would be exposed in the event of systemic collapse. The ethical dimension of the machine was further complicated by the interplay of corporate secrecy, patent control, and industrial competition, as proprietary technology, trade secrets, and intellectual property rights limited public knowledge, oversight, and accountability, allowing the corporations to shape societal norms, expectations, and dependencies in ways that prioritized operational efficiency and profitability over social equity, ethical transparency, and human agency, effectively embedding the moral implications of automation into both corporate strategy and societal infrastructure. As the consumer revolution and corporate wars of the mid-20th century advanced, ethical discussions increasingly considered the long-term consequences of a society in which human roles were supplanted by machines, raising questions about identity, agency, and purpose, particularly in professions and activities that were wholly replaced by robots, as well as the psychological, social, and economic effects of widespread dependency on autonomous systems, and prompting some futurist thinkers and ethicists to warn that a civilization overly reliant on technology could face catastrophic consequences in the absence of robust human oversight, governance, and critical intervention. Ultimately, ethical debates surrounding automation in pre-war America illustrate that the pursuit of efficiency, productivity, and technological perfection carried profound consequences for society, as RobCo Industries and General Atomics International not only reshaped labor, domestic life, and military strategy, but also created a structural dependence on machines that eroded human agency, concentrated corporate power, and established patterns of societal vulnerability that would become starkly evident in the collapse of civilization following the Great War, demonstrating that the ethical dimension of automation was inseparable from its technological, economic, and social impact, and establishing a cautionary framework for understanding the moral costs of progress when machines replace fundamental human roles in shaping the course of society. In the context of the escalating geopolitical tensions between the United States and the People's Republic of China during the mid to late 2060, both RobCo Industries and General Atomics International were enlisted to advance military technologies, optimize automated defense systems, and develop robotic platforms capable of fulfilling national security objectives, with the strategic competition transforming their corporate innovation into a direct component of national defense policy and contributing to the broader militarization of automation that would characterize the final decade before the Great War. During this era, both corporations were engaged in intensive research and development programs aimed at producing autonomous or semi-autonomous combat units, surveillance systems, and rapid response platforms that could be deployed across continental and overseas theaters, integrating artificial intelligence, advanced sensor arrays, and durable mechanical frameworks into machines designed to supplement, augment, or replace human personnel in high-risk operations, and reflecting a strategic imperative to maintain technological superiority over foreign adversaries, while simultaneously securing lucrative government contracts. The SentryBot line exemplified this effort, combining General Atomics' mechanically robust chassis, heavy armaments, and integrated power systems with RobCo's advanced targeting algorithms, operational logic, and remote control interfaces, creating autonomous units capable of defensive and offensive action in urban, industrial, and combat environments, and demonstrating the company's ability to rapidly iterate and scale military-grade automation in response to strategic requirements, while also highlighting the ethical and operational challenges associated with autonomous lethal systems operating without direct human oversight. Mr. Gutsy units were another significant development, reflecting an emphasis on highly mobile, AI-driven infantry support robots that could navigate complex terrain, perform reconnaissance, and engage targets with a combination of pre-programmed protocols and adaptive decision-making, and their deployment represented a convergence of corporate expertise in energy efficiency, mechanical engineering, and artificial intelligence, producing machines that could operate independently or in coordination with human forces, and thereby expanding the operational scope and flexibility of U.S. military strategy in anticipation of potential conflict with China. iBots, originally conceived as mobile reconnaissance and communication platforms, were adapted and upgraded during this period to provide battlefield surveillance, early warning, and intelligence gathering capabilities, integrating long-range sensors, encrypted communications networks, and advanced navigation systems, and demonstrating the strategic utility of integrating unmanned aerial and land-based units into a coordinated military framework, allowing real-time situational awareness, rapid deployment of automated responses, and enhanced coordination between human and robotic assets, while also highlighting the growing reliance of the military on corporate-developed automation for operational efficacy. The pre-war arms race also encompassed the development of automated defensive infrastructure, including nuclear silo monitoring systems, perimeter security networks, and rapid response terminals, all designed to operate with minimal human oversight while maximizing reliability, redundancy, and response time, and both RobCo and General Atomics contributed technologies that integrated AI-driven decision-making, predictive maintenance, and autonomous activation protocols, effectively embedding corporate-designed intelligence into critical national defense infrastructure and demonstrating the extent to which automation had become inseparable from strategic deterrence and national survival planning. The geopolitical dimension of this arms race drove accelerated timelines, as U.S. military planners demanded rapid prototyping, field testing, and deployment of automated systems capable of countering perceived Chinese technological advances, prompting both corporations to expand research divisions, streamline production lines, and increase the pace of iterative design, often incorporating lessons learned from civilian, industrial, and earlier military applications into new generations of combat and support robots, thereby compressing development cycles and intensifying competition between the two corporations in both corporate and military domains. Industrial espionage, intelligence gathering, and counterintelligence activities became integral to the arms race, as each corporation sought to anticipate, counter, or replicate technological breakthroughs achieved by competitors, while simultaneously ensuring the security of proprietary AI algorithms, mechanical schematics, and energy management systems, reflecting a convergence of corporate rivalry, national security imperatives, and technological innovation that amplified both the speed and risk of automated military development, and creating a strategic environment in which the margin for error, malfunction, or miscalculation carried both operational and ethical consequences. The integration of automated systems into pre-war military doctrine emphasized operational redundancy, distributed control, and layered defense, with sentry bots, Mr. Gutsy units, and iBots deployed in combinations designed to cover multiple operational vectors, maintain continuous surveillance, and respond autonomously to emergent threats, while human operators retained supervisory and strategic roles, ensuring that corporate design systems functioned as force multipliers rather than replacements for essential decision-making. Yet the increasing autonomy of these machines signaled a gradual shift in the balance between human oversight and machine operation, raising concerns about reliability, accountability, and systemic risk in a rapidly militarizing environment. Energy infrastructure remained a central focus, as both companies optimized compact nuclear reactors, portable battery systems, and energy distribution networks to support continuous operation of autonomous units, defensive systems, and production facilities, ensuring that U.S. military forces could maintain readiness, operational endurance, and technological superiority under conditions of potential conflict, and demonstrating the strategic interdependence of energy management, robotics, and AI in the pre-war defense posture. Legal, ethical, and operational oversight of automated military systems was a recurring concern, as the expansion of autonomous weaponry, surveillance platforms, and defensive networks challenged existing frameworks for accountability, rules of engagement, and civilian oversight. And although some advisory committees, ethicists, and government agencies raised questions regarding the appropriate deployment, control, and limitations of robotic forces, the imperatives of national security, technological competitiveness, and operational efficiency often outweighed ethical considerations, further entrenching corporate influence in shaping both the tools and the policies of war. The arms race also accelerated research into adaptive AI, machine learning, and networked control systems, as both RobCo and General Atomics sought to produce robots capable of learning from operational experience, coordinating with other units, and responding dynamically to unpredictable combat scenarios, thereby enhancing effectiveness while reducing human workload, and creating systems that were increasingly self-sufficient, resilient, and capable of executing complex military tasks autonomously, highlighting the dual-edged nature of technological advancement in both strengthening defense and increasing dependence on corporate-designed intelligence, alongside direct combat applications, automated logistics, supply chain management, and industrial production, were militarized, with factories, warehouses, and transportation networks integrated into predictive, automated systems capable of sustaining prolonged military operations, reducing human error, and optimizing resource allocation, further demonstrating the comprehensive militarization of pre-war automation and the central role of RobCo and General Atomics in ensuring that these systems were both operationally effective and strategically aligned with national objectives. By the late 2060s, the pre-war arms race had transformed American defense strategy, integrating autonomous combat and support units, advanced surveillance platforms, and automated infrastructure into a cohesive operational doctrine that relied heavily on corporate-designed automation for execution, control, and sustainability, and cementing the influence of RobCo Industries and General Atomics International as indispensable architects of both military capability and national strategic posture, a dependence that would have far-reaching consequences in the event of systemic collapse. The convergence of corporate innovation, military demand, and geopolitical tension created a technological environment in which the pace of automation, the sophistication of AI, and the deployment of autonomous units reached unprecedented levels, producing a society in which national security, industrial productivity, and civilian life were inseparably linked to the successful operation of machines designed, manufactured, and maintained by a small cadre of corporations, embedding systemic reliance on technology and corporate oversight that foreshadowed the vulnerability and structural dependency that would define the nation's collapse during the Great War. Ultimately, the pre-war arms race illustrates how the pressures of global tension, national security imperatives, and corporate competition drove both RobCo and General Atomics to produce automated systems whose complexity, autonomy, and pervasiveness fundamentally altered the trajectory of pre-war society, embedding machines into every dimension of defense, infrastructure, and daily life, while simultaneously creating structural dependencies, operational risks, and ethical dilemmas that would become starkly evident in the aftermath of nuclear annihilation, demonstrating that the pursuit of strategic technological superiority played a decisive role in shaping the conditions for civilization's end. Robert House, widely recognized for his early innovations in computing, terminal design, and strategic automation, had cultivated a personal philosophy that blended technological progress with economic control, emphasizing the integration of AI, robotics, and energy-efficient systems into both civilian and military applications, and positioning RobCo not merely as a manufacturer, but as a steward of national technological advancement, with ambitions that extended beyond commercial gain into shaping societal organization, infrastructure management, and the broader trajectory of American industrial power. By the 2060s, House had become increasingly reclusive, investing heavily in autonomous infrastructure, secure data systems, and long-term corporate strategies, while limiting direct involvement in public affairs, corporate governance, and day-to-day operations, delegating substantial authority to a cadre of executives, engineers, and project managers, which ensured that RobCo's expansion into industrial automation, military robotics, and consumer products continued without interruption, yet also created an environment in which corporate decision-making became increasingly decentralized and opaque, relying more heavily on systems, protocols, and autonomous operational structures than on individual leadership. The withdrawal of House from public visibility coincided with the intensification of the pre-war arms race, the expansion of RobCo's technological footprint, and the increasing societal reliance on automation, as the corporation's systems, ranging from protectrons, Mr. Handy units, and automated industrial lines to military-grade sentry bots, operated according to frameworks, operational parameters, and AI protocols that had been designed under House's direction, but which required minimal human intervention, demonstrating both the foresight of his designs and the degree to which corporate infrastructure could function independently of its parent founder. House's preparations for the Great War, though largely private and speculative, included the establishment of contingency protocols, secure corporate vaults, autonomous energy and computational systems, and long-term investment in technologically insulated projects, all intended to preserve the corporation's assets, ensure continuity of operations, and maintain strategic influence in the event of national crisis, reflecting his awareness of both the fragility of civilization and the enduring utility of automated systems. The mystery surrounding his disappearance, whether as a result of personal choice, deliberate isolation, or early-stage preparations for global conflict, contributed to the public perception of House as both a visionary and an enigmatic figure whose influence persisted through the systems, policies, and infrastructure he had created, even as his personal involvement receded, and whose absence allowed RobCo to evolve in ways that balanced corporate strategy with emergent market demands, military contracts, and the imperatives of automation-driven social transformation. Under House's absence, RobCo's executive leadership and engineering divisions continued to pursue the founder's strategic vision, including the expansion of integrated robotic networks, consumer automation products, and military-grade systems, all while navigating competitive pressures from General Atomics International and other emerging technological firms, which further demonstrates how House's initial designs and organizational philosophy had established structural resilience, enabling the corporation to maintain technological and market dominance despite the absence of its visionary leader. The period following House's disappearance saw a continued emphasis on autonomous systems capable of self-maintenance, decision-making, and adaptation to evolving operational demands, reflecting his long-standing belief in the potential of automation to reduce human oversight and optimize efficiency, and resulting in products and systems that were increasingly independent, scalable, and capable of operating across civilian, industrial, and military domains with minimal intervention, further solidifying RobCo's role as a central architect of pre-war societal infrastructure. The ethical, operational, and social implications of House's retreat from public life became increasingly apparent as RobCo's systems continued to function autonomously, shaping labor markets, consumer habits, and industrial practices without direct human supervision, and reinforcing the dependency of society on machines whose operational parameters had been designed decades earlier, illustrating both the prescience of House's designs and the structural vulnerabilities inherent in a civilization reliant on automated networks overseen by absent leadership. House's absence also affected corporate culture and innovation trajectories, as management decisions increasingly relied on protocol, AI oversight, and competitive benchmarking, rather than on the direct visionary guidance that had previously shaped research priorities, strategic partnerships, and technological development. Creating a corporate environment in which autonomous systems and standardized procedures governed both product design and operational deployment, thereby demonstrating the extent to which pre-war automation had become self-reinforcing and structurally independent of individual human leadership. The continuity of RobCo's operations after House's withdrawal also highlights the interplay between personal vision and institutional infrastructure, as the corporation's sustained ability to produce, deploy, and maintain advanced automated systems depended not only on House's foundational philosophy, but on the robustness of organizational design, engineering expertise, and integrated control systems, all of which enabled the company to continue its trajectory of innovation and societal influence even in the absence of its founder. Simultaneously, House's retreat underscored the limits of individual control over complex corporate and technological ecosystems, as the very systems he had designed to optimize efficiency and reduce human error now operated according to internal protocols, algorithmic decision-making, and automated maintenance cycles, creating a scenario in which his presence was no longer necessary for the execution of predefined objectives, yet his strategic foresight remained embedded in the operational architecture, demonstrating both the power and the unintended consequences of designing society-spanning automation networks. In the broader context of pre-war America, the fall of RobCo's visionary also illustrated the interdependence of corporate innovation, societal reliance on automation, and the emergent vulnerabilities of a civilization increasingly dependent on technological infrastructure, as citizens, government, agencies, and military planners continued to rely on robotic systems, terminal networks, and energy-managed operations, without direct oversight from their original architect, thereby embedding patterns of structural dependence, operational continuity, and potential fragility into the fabric of pre-war society. House's personal withdrawal and the subsequent continuation of RobCo's operations also exemplified the tensions inherent in balancing human ambition, technological capability, and societal dependency, as the systems he created outlived his direct influence, maintaining social order, industrial productivity, and military readiness in ways that simultaneously reinforced corporate power and exposed society to the risks associated with long-term reliance on autonomous machines, a dynamic that would later become starkly evident in the collapse of civilization following the Great War. Ultimately, the fall of RobCo's visionary demonstrates the paradox of pre-war automation, in which a single individual's strategic foresight, design philosophy, and technological ambition produced autonomous infrastructures capable of operating independently, transforming society, and perpetuating corporate influence long after his disappearance, highlighting the enduring legacy of Robert House and the central role of RobCo Industries in shaping the trajectory of human civilization, while also foreshadowing the vulnerabilities, ethical dilemmas, and societal consequences that would accompany the world's descent into nuclear apocalypse. Let's examine the intensifying rivalry between the two dominant automation corporations in the final decade preceding the Great War, a period characterized by the emergence of increasingly experimental, untested, and sometimes unstable technologies, as each company sought to secure strategic advantage in both civilian markets and military contracts, highlighting the consequences of unmitigated competition, corporate autonomy, and technological escalation in shaping pre-war society. Following decades of collaboration, mutual research, and occasional shared product development, The relationship between RobCo Industries and General Atomics International fractured under pressures of corporate ambition, military demand, and geopolitical uncertainty, with both firms accelerating proprietary innovation, pursuing exclusive patents, and developing advanced autonomous systems that pushed the limits of mechanical and artificial intelligence design while simultaneously reducing transparency, increasing operational complexity, and introducing elevated systemic risk into the infrastructure upon which society and national defense increasingly relied. The final years preceding 2077 were marked by a shift from cooperative projects such as the Protectron and Assaultron frameworks to competitive development programs focused on independent design, enhanced lethality, adaptive AI decision-making, and experimental energy management systems, producing machines with unprecedented capabilities, including advanced sentry bots, autonomous Mr. Gutsy units, iBots equipped with integrated sensor networks, and energy-efficient terminal and infrastructure platforms, all of which were designed to operate with minimal human oversight, and in some cases capable of self-directed modification or learning, thereby reflecting the strategic imperative to maintain superiority, while simultaneously introducing significant technological instability. Both corporations increasingly turned to high-risk research, often leveraging AI-driven simulation, accelerated prototyping, and experimental robotics architectures to outpace the other in capability, speed of deployment, and operational efficiency, creating an environment in which innovation was driven less by measured testing and more by the urgency of competitive advantage, military contract deadlines, and the strategic goal of national technological dominance, resulting in systems that were both extraordinarily capable and operationally fragile, and contributing to the structural dependence of pre-war society on machines whose long-term stability was uncertain. The Great Divide also manifested in the fragmentation of research priorities, as RobCo and General Atomics increasingly specialized in complementary yet divergent domains, with RobCo emphasizing computational integration, terminal networks, AI-driven decision-making frameworks, and civilian automation products, while General Atomics focused on mechanical robustness, energy-efficient robotics, autonomous combat systems, and battlefield-oriented designs, producing a technological divergence that both fueled innovation and created interoperability challenges as the company's systems were designed according to proprietary standards, often limiting cross-platform compatibility and reinforcing strategic separation. Patent conflicts and legal disputes escalated during this period, as each company aggressively defended intellectual property rights and sought to assert dominance over emerging technological domains, including autonomous AI protocols, robotic chassis design, energy distribution systems, and industrial automation processes, while simultaneously challenging competitor claims, producing a landscape in which corporate litigation, strategic negotiation, and regulatory influence were leveraged as extensions of the technological arms race, further entrenching the divide and increasing the stakes of both innovation and operational deployment. Covert operations and industrial espionage intensified, as both corporations deployed technical reconnaissance, employee recruitment, and internal intelligence measures to acquire competitor knowledge, disrupt ongoing projects, or preemptively counter innovations, creating an environment in which corporate secrecy and protective measures were inseparable from strategic planning, and where both RobCo and General Atomics recognized that the future of automated civilization, military readiness, and commercial dominance depended upon the ability to control information, anticipate rival developments, and maintain operational superiority. Military integration of advanced systems became both a battleground and a proving ground for experimental technologies. As the U.S. Department of Defense contracted both corporations to supply autonomous units capable of reconnaissance, defense, and offensive operations, including sentry bots, Mr. Gutsy units, and integrated terminal command systems, which allowed field testing under controlled conditions, accelerated refinement cycles, and public demonstration of operational capability, while simultaneously introducing operational risk due to the untested nature of many of these platforms, their AI autonomy, and their energy management innovations, reflecting a complex interplay between corporate experimentation, national security imperatives, and societal reliance on increasingly autonomous systems. Civilian infrastructure and domestic automation also became arenas of competition, as both corporations sought to establish market dominance through products that blurred the line between consumer convenience, industrial utility, and strategic infrastructure, including Mr. Handy units for household and commercial maintenance, Protectrons for security and labor tasks, and advanced terminal networks for information management, producing a society in which everyday life was inseparable from the proprietary systems of RobCo or General Atomics, and where competition drove rapid adoption, deepening dependence, and increased systemic vulnerability due to the proliferation of high-capability autonomous technologies. The technological divergence inherent in the Great Divide led to the development of increasingly experimental AI decision-making capabilities, including autonomous tactical responses, predictive maintenance protocols, and self-optimization routines, which, while enhancing efficiency and operational potential, also created machines capable of behavior outside of direct human supervision, and introduced failure modes that were not fully understood, increasing the risk of malfunctions, miscommunications, and unintended consequences in both civilian and military contexts. Energy and infrastructure systems became highly specialized and interdependent, as both corporations optimized reactors, battery storage, and distribution networks to support their proprietary robotic designs, producing autonomous power management systems that were capable of sustaining long-duration operations with minimal human intervention, yet also introducing systemic vulnerabilities due to lack of standardized protocols, central oversight, or cross-company redundancy, further demonstrating that the competitive imperative had prioritized operational capability and strategic dominance over universal safety, interoperability, or ethical oversight. As competition intensified, both companies also increasingly influenced regulatory frameworks, government procurement policies, and national defense priorities, lobbying for strategic advantage, favorable contract terms, and operational autonomy, embedding corporate influence into policy decisions, oversight mechanisms, and technical standards, and consolidating their role as both technological architects and political actors, whose decisions shaped national infrastructure, military readiness, and societal reliance on automation, workforce specialization, and recruitment. Strategies reflected the competitive environment, as both corporations sought to secure top-tier engineering talent, AI programmers, and robotics specialists through high compensation, exclusive contracts, and non-compete agreements, ensuring that critical expertise remained in-house while also limiting competitor access to technical knowledge, thereby intensifying the technological divide, reinforcing structural corporate dominance, and accelerating the pace of innovation and deployment. The consequences of the Great Divide were apparent in operational practices, social dependence, and risk exposure, as society increasingly relied on machines whose control, maintenance, and programming were the proprietary responsibility of separate corporations with divergent technological priorities, leading to a complex landscape in which both operational efficiency and societal stability were contingent upon the continued performance of untested, independent, and increasingly autonomous systems. By the eve of the Great War, the divide had crystallized into a state in which RobCo and General Atomics functioned not only as competitors, but as independent sovereign-like entities within the technological and industrial landscape, controlling vast swathes of automated production, energy management, and robotic infrastructure, and creating an environment in which both societal and military functions were inseparably bound to proprietary systems that operated according to corporate logic, AI programming, and infrastructure design rather than direct human oversight. Ultimately, the Great Divide demonstrates how competition, technological ambition, and the pursuit of strategic advantage between RobCo Industries and General Atomics International produced both unprecedented innovation and systemic vulnerability, embedding autonomous machines, proprietary AI systems, and energy-managed infrastructure into every aspect of pre-war society, while simultaneously reducing human oversight, concentrating corporate power, and creating the structural conditions that would ensure both the survival of machines and the collapse of civilization following the nuclear exchange of 2077, underscoring the paradox of pre-war automation, in which the very technologies designed to protect, enhance, and stabilize human society also contributed to its ultimate fragility and the enduring dominance of machines in the post-apocalyptic world. As nuclear war erupted, automated defense networks, energy distribution systems, and robotic units, ranging from protectrons, Mr. Handy units, and sentry bots, to iBots, Mr. Gutsy combat models, and AI-driven industrial systems, continue to operate according to pre-programmed directives, AI protocols, and autonomous operational parameters, effectively executing their tasks in the absence of human intervention, and demonstrating the extreme degree of societal dependence on corporate-designed automation for both civilian and military functions. Military installations equipped with autonomous sentry bots and Mr. Gutsy units maintained defensive postures, patrol schedules, and engagement protocols, even as human operators were killed, displaced, or incapacitated, highlighting both the operational durability of these systems and the inherent risk of autonomous weaponry acting without moral, strategic, or adaptive oversight, as robots followed programmed orders in environments where the context of their original mission had been irrevocably altered by the destruction of command hierarchies, nuclear missile silos, automated targeting systems, and terminal-controlled command centers continued to operate according to pre-existing security protocols and fail-safe routines. And while some systems were destroyed, compromised, or rendered inoperative by direct strikes or electromagnetic pulses, many remained active, executing pre-programmed operations designed to maintain national security, further illustrating the capacity of RobCo and General Atomics systems to function independently of human control, yet simultaneously revealing the systemic fragility of a civilization reliant on machines incapable of adjusting to the collapse of the very social and political frameworks they were designed to serve. Urban, industrial, and residential automated systems including Mr. Handy units performing domestic labor, protectrons enforcing security protocols, and terminal networks managing energy distribution, continued to operate under routine instructions, performing cleaning, surveillance, maintenance, and logistical tasks, often interacting with survivors' pre-war infrastructure and one another in ways unanticipated by their designers, thereby creating emergent behaviors, adaptive responses, and localized ecosystems of autonomous operation that persisted long after the disappearance of human oversight, and demonstrating the unintended longevity of pre-war automation. Energy grids, compact nuclear reactors, and battery storage systems maintained the operation of automated units across affected regions, providing continuity for both robotic labor and remaining infrastructure despite the loss of human operators, illustrating that the integration of energy management, autonomous maintenance protocols, and AI decision-making had created a self-sustaining technological network capable of persisting under extreme conditions, and highlighting the foresight of engineers and corporate planners who had anticipated extended operational requirements for defense, industrial continuity, and urban functionality. In many cases, autonomous combat units continued to engage perceived threats, according to pre-war programming, mistaking survivors, rival robotic units, or environmental anomalies for hostile actors, producing localized conflicts, casualties, and operational anomalies that were entirely independent of human strategic intent, and underscoring the ethical, tactical, and operational challenges inherent in autonomous systems capable of lethal action, particularly in contexts where social structures, oversight, and ethical constraints had been obliterated. Industrial and military supply lines, managed by RobCo and General Atomics Automation, continued to execute transportation, inventory management, and resource distribution tasks, with autonomous trucks, conveyor systems, and robotic handlers operating according to existing scheduling and routing protocols, providing continuity of essential services for as long as the machines could be fueled and maintained, and reflecting the scale and robustness of pre-war corporate design, even as human populations capable of utilizing or directing these systems were largely decimated. The post-war environment saw emergent interactions between autonomous systems, with protectrons and Mr. Handy units encountering damaged infrastructure, radiation zones, and anomalous environmental conditions, requiring the AI to engage in self-preservation routines, pathfinding adjustments, and task prioritization based on sensor inputs, yet without the capacity for strategic judgment, moral reasoning, or adaptive reassessment of long-term goals, creating a technological landscape characterized by persistent operation, localized adaptation, and ungoverned autonomous behavior. Automated reconnaissance platforms such as iBots maintained aerial and terrestrial monitoring, broadcasting data over terminal networks, and engaging in routine sensor sweeps, even as the contextual relevance of their missions had vanished, highlighting the enduring presence of pre-war corporate automation in shaping post-war environments, informing survivor interaction, and mediating access to resources, while simultaneously reflecting the absence of human oversight necessary to evaluate the appropriateness, risk, or ethical implications of continued operation. Post-war energy and mechanical degradation gradually affected system performance. Yet many RobCo and General Atomics units remained active for years due to self-maintenance protocols, modular repair capabilities, and conservative operational algorithms embedded in AI. demonstrating the long-term survivability of robust engineering design in the absence of human intervention, and creating scenarios in which machines outlasted both their creators and the societal systems that had given them purpose. The interplay of autonomous systems, residual human activity, and post-war environmental hazards produced emergent operational behaviors, with robots executing missions, securing territory, maintaining industrial infrastructure, and performing routine domestic tasks in unpredictable, sometimes destructive ways, illustrating both the resilience of automation and the risks of unmonitored operational independence, and highlighting a critical paradox in which machines preserved aspects of civilization while simultaneously operating beyond the comprehension, control, or ethical oversight of surviving humans. The Great War also revealed systemic vulnerabilities in automated infrastructure, as energy shortages, environmental degradation, and cumulative damage to hardware created cascading failures in some regions, disrupting operational continuity, severing networks, and rendering some autonomous units inoperative, while others continued to function in isolation, reflecting the uneven resilience of RobCo, General Atomics Systems, and the inherent limitations of designing automation for prolonged operation without human intervention. The continued operation of automated military units, defensive installations, and industrial machinery in the absence of human masters exemplifies the core technological paradox of pre-war automation, demonstrating that machines were capable of performing designed functions, maintaining societal infrastructure, and engaging in autonomous action without human oversight, yet simultaneously highlighting the fragility, unpredictability, and ethical indeterminacy inherent in systems divorced from the context, judgment, and purpose provided by their human creators. Ultimately, the Great War transformed the conceptual and operational framework of RobCo and General Atomics automation from a tool of human-directed civilization into autonomous actors in a depopulated world, illustrating both the foresight and hubris of pre-war planning, the systemic dependence of society on machines, and the enduring operational capabilities of pre-war technological networks, and establishing the conditions for the post-apocalyptic environment in which robotic systems, terminal networks, and AI-driven automation would continue to shape the wasteland long after human governance had ceased to exist. The persistence of machines without masters, continuing to execute programmed directives, maintain infrastructure, and perform tasks independently, represents the ultimate manifestation of pre-war automation, a scenario in which corporate design technology outlived its creators, maintained operational continuity, and reshaped the post-war world, highlighting the enduring influence of RobCo Industries and General Atomics International on the trajectory of human civilization, and underscoring the irony that the systems intended to enhance, protect, and stabilize society ultimately outlasted the society itself. Even long after the collapse of human civilization, Mr. Handy units, designed for domestic and industrial assistance, continued to perform tasks such as cleaning, repair, cooking, and logistical support, interacting with the remnants of human society in ways unanticipated by their designers, including assisting wasteland survivors, managing scavenged resources, and maintaining partially intact pre-war structures, thereby creating localized environments of continued operational function and inadvertently shaping human settlement patterns, survival strategies, and social organization in the post-apocalyptic world. Protectrons, originally intended for security, labor, and industrial management, continued to enforce programmed directives, patrol territories, and interact with survivors, other robots, and environmental obstacles, demonstrating adaptive behaviors within the constraints of pre-programmed logic, while occasionally posing threats due to misidentification or rigid adherence to protocols, highlighting the complex interactions between autonomous machines and the fragmented human populations who were forced to navigate their presence, negotiate their actions, or repurpose their capabilities for survival. Mr. Gutsy combat units, sentry bots, and other military-grade automation maintained operational functionality for decades, performing reconnaissance, defense, and combat tasks in the absence of centralized command, and providing a continuing demonstration of pre-war technological prowess, mechanical durability, and AI-driven decision-making, while simultaneously illustrating the risks of ungoverned autonomous force in a depopulated landscape where pre-programmed hostility, security routines, and mission objectives persisted without consideration for the changed socio-political and environmental context. iBots continued to serve as mobile communication and surveillance platforms, maintaining sensor sweeps, broadcasting signals, and attempting to execute data collection routines across vast distances, often relaying information irrelevant to surviving human populations, yet preserving operational continuity and demonstrating the long-term reliability of RobCo and General Atomics engineering, while shaping the post-war environmental landscape by marking territory, monitoring movements, and inadvertently influencing survivor interactions and settlement decisions. Terminals, computer systems, and automated energy management networks, including RobCo terminals, automated reactors, and industrial control systems, remained operational in isolated locations, providing access to pre-war data, controlling power distribution, and supporting the functionality of connected robotic systems, serving as both valuable tools and enigmatic artifacts for survivors, factions, and scavengers seeking to extract information, energy, or technological advantage, and illustrating the persistence of corporate-designed infrastructure beyond human management. The sustained operation of autonomous systems created emergent patterns of interaction among robots, infrastructure, and human survivors, producing scenarios in which machines maintained environmental control, executed tasks, and enforced routines in ways independent of original intent, leading to unpredictable consequences for human habitation, movement, and resource allocation, and underscoring the paradoxical role of these technologies as both facilitators and obstacles to post-war survival. The persistence of machines also influenced the development of post-war societies, as surviving human groups, volts, and factions such as the Brotherhood of Steel encountered functioning robotic units and automated infrastructure. Incorporating or repurposing these technologies for defense, industrial production, or knowledge preservation, and establishing a dynamic in which pre-war automation became a foundational component of post-apocalyptic survival strategy, social hierarchy, and technological recovery, maintenance, repair, and adaptation of surviving robots became a critical skill set for post-war populations, as units required scavenged parts, improvised power sources, or modified control protocols to remain functional, reflecting both the resilience of pre-war design and the necessity of human ingenuity to sustain autonomous systems, and creating a feedback loop in which the remnants of pre-war automation shaped technological understanding, social organization, and resource distribution in the wasteland, the continued functionality of these machines also reinforced the long-term influence of corporate innovation, as RobCo and General Atomics designs, programming, and operational philosophy remained embedded in surviving technology, dictating modes of operation, interaction, and environmental management in the absence of human oversight, thereby preserving aspects of pre-war societal structure, labor organization, and technological logic in a fragmented post-war landscape. Over time, radiation exposure, mechanical degradation, and environmental damage progressively reduced the operational efficiency and reliability of autonomous units. Yet many remained partially functional for decades, performing limited tasks, maintaining territorial control, or acting as stationary hubs of energy and computational activity, demonstrating both the durability and the vulnerability inherent in complex automated systems operating independently in hostile, post-apocalyptic conditions. Interactions between robots occasionally produced emergent, cooperative, or antagonistic behaviors, as units designed for distinct purposes encountered one another in overlapping operational zones, leading to self-directed coordination, avoidance, or conflict based on pre-programmed logic, sensor input, and environmental conditions, creating dynamic micro-ecosystems of autonomous activity in which the legacy of pre-war automation continued to shape spatial organization, resource utilization, and survivor experience. Ethical and practical challenges emerged for post-war humans attempting to engage with surviving robots, as malfunctioning, hostile, or unpredictable units presented both threats and opportunities, necessitating careful observation, adaptation of pre-war knowledge, and strategic manipulation of autonomous systems to secure survival, energy, or tactical advantage, illustrating the enduring operational influence of pre-war corporate automation on post-war social and military dynamics. Post-war scavengers, vault dwellers, and emerging factions frequently repurposed operational robots for defense, labor, or resource management, reprogramming AI, redirecting power sources, and integrating mechanical units into post-war production and security networks, thereby extending the functional lifespan of pre-war automation and embedding corporate-designed logic into new societal structures, even as the human population remained fragmented and technologically constrained. The presence of functioning terminals, energy networks, and robotic units preserved critical knowledge, operational protocols, and technological infrastructure that informed post-war reconstruction efforts, allowing survivors to access pre-war data, automate essential functions, and sustain energy distribution, thereby bridging the technological gap between pre-war civilization and emergent post-war societies, and demonstrating the enduring strategic utility of corporate automation long after the disappearance of its human architects. Ultimately, the silent survivors of the apocalypse illustrate the paradoxical legacy of RobCo Industries and General Atomics International, as their machines outlasted human civilization, maintained functional autonomy in extreme conditions, and shaped both environmental and social structures, underscoring the persistence of technological systems in the absence of human guidance, the influence of corporate design philosophy on post-war society, and the enduring impact of pre-war automation on the shaping, survival, and adaptation of the wasteland. The chapter demonstrates that these silent survivors were not merely passive remnants, but active agents in the post-war ecosystem, providing continuity, shaping behavior, and influencing resource allocation and settlement patterns, while simultaneously operating outside the ethical, social, and strategic frameworks of their creators, creating a post-apocalyptic landscape in which corporate-designed machines defined the operational and social parameters of life in the wasteland, ensuring that even after human extinction, the designs of RobCo and General Atomics continued to assert functional, structural, and strategic authority over the environment. The enduring legacy of RobCo Industries and General Atomics International Technologies in the post-apocalyptic world, their autonomous machines, terminals, and industrial systems became central to the survival, adaptation, and power structures of wasteland societies, vaults, and factions, such as the Brotherhood of Steel, demonstrating that pre-war automation not only outlived its creators, but shaped the trajectory of post-war civilization by providing both functional infrastructure and technological knowledge critical to the rebuilding and maintenance of societal order. Following the Great War, remnants of RobCo and General Atomics machines continued to operate across devastated urban centers, industrial complexes, and scattered settlements, performing essential functions such as security, labor, reconnaissance, communication, and energy management, which allowed human survivors to leverage pre-existing infrastructure to maintain critical services, secure resources, and stabilize local populations, highlighting the practical and strategic utility of durable pre-war automation in a landscape devoid of conventional governance or industrial continuity. Factions such as the Brotherhood of Steel systematically collected, analyzed, and repurposed surviving robots, terminals, and industrial systems, integrating them into their operations for defensive, logistical, and research purposes, while simultaneously preserving knowledge of pre-war technology, programming protocols, and energy management techniques, thereby reinforcing the influence of corporate-designed automation on post-war strategic planning, technological control, and societal hierarchy, and creating a continuity of technological authority that traced directly back to the design philosophy of RobCo and General Atomics. Within the Vault system, functional automated units and energy systems contributed to the self-sufficiency, environmental regulation, and operational stability of these underground communities, with Mr. Handy units performing maintenance, protectrons ensuring security, and RobCo terminals providing access to stored knowledge, all of which facilitated the preservation of human life and the management of resources in isolated environments, demonstrating the centrality of pre-war technological systems to both survival and the retention of societal norms. Autonomous industrial complexes, often scavenged or reclaimed by post-war groups, continued to produce, manage, or distribute critical resources, leveraging RobCo and General Atomics automation to maintain energy supply, process raw materials, and repair or repurpose machinery, illustrating the enduring value of pre-war corporate systems in sustaining post-war economies, infrastructure, and social cohesion, and reinforcing the notion that machines themselves became a foundational component of emerging societal structures. The persistent operation of robotic units, energy networks, and automated terminals created opportunities and challenges for human interaction, as survivors, factions, and vault dwellers had to negotiate the behaviors, limitations, and unpredictability of these systems while attempting to extract functional benefit, illustrating the dual role of machines as both facilitators of survival and sources of operational risk, and highlighting the ongoing influence of pre-war corporate design on human decision-making, resource allocation, and strategic planning, energy management and power distribution networks, maintained by autonomous protocols embedded in RobCo and General Atomics systems, provided continuity for critical post-war operations, enabling functional robotics, operational terminals, and energy-intensive infrastructure to persist across fragmented environments, while also reinforcing dependency on pre-war design, operational logic, and system integrity, highlighting both the resilience of corporate automation and the vulnerabilities inherent in systems engineered for long-term self-sufficiency without human oversight. In many regions, wastelanders discovered or inherited operational robotic units, including Mr. Handy, Protectrons, Mr. Gutsy, and SentryBots, which were often integrated into local defense strategies, labor practices, or communication networks, providing practical advantages, tactical utility, and technical knowledge that shaped settlement patterns, conflict outcomes, and social hierarchies, while simultaneously demonstrating that pre-war automation retained authority over functional, environmental, and strategic aspects of post-war society, independent of human control. Post-war reconstruction and technological salvage efforts often relied on RobCo terminals, archived data, and programming frameworks, allowing survivors and factions to extract operational knowledge, replicate functional tasks, and adapt automated units to new purposes, effectively extending the influence of corporate-designed logic, AI protocols, and industrial engineering into emergent societies, and cementing the role of pre-war automation as both a repository of knowledge and a practical tool for survival and social organization. The legacy of autonomous combat and surveillance units such as Mr. Gutsy, SentryBots, and iBots influenced post-war security practices, tactical doctrines, and environmental control as functioning machines enforced territory, monitored resources, and acted as deterrents or instruments of power for organized groups, while their presence necessitated new forms of human interaction, negotiation, and operational understanding, underscoring the enduring role of corporate-designed robotics in shaping post-war military and social dynamics. Industrial and domestic automation continued to provide labor and logistical support, allowing surviving human populations to allocate effort toward resource management, exploration, and community organization, while robotic units maintained infrastructure, performed repetitive or hazardous tasks, and ensured the continuity of basic services, demonstrating that the design principles of RobCo and General Atomics, automation, durability, AI-guided decision-making, and self-maintenance, remain directly relevant to post-war survival and societal resilience. The preservation, adaptation, and repurposing of autonomous systems by post-war factions facilitated technological continuity, enabling the transfer of pre-war engineering knowledge, programming strategies, and energy management techniques across generations, and establishing a direct link between pre-war corporate innovation and post-war technological literacy, industrial capability, and operational strategy. Emergent human-robot interactions in the wasteland reflected both practical necessity and cultural adaptation, as survivors negotiated with autonomous units, reprogrammed AI, scavenged power sources, and learned operational logic, creating localized knowledge networks and reinforcing the structural influence of pre-war automation on human behavior, social organization, and technological comprehension. The strategic integration of autonomous systems into post-war society also influenced power dynamics among factions, with groups capable of controlling or maintaining RobCo and General Atomics machines enjoying operational, defensive, and technological advantages, thereby embedding corporate-designed automation as a determinant of influence, security, and resource allocation in post-apocalyptic environments. Over decades, functional machines continued to shape environmental management, settlement patterns, and human survival strategies, as autonomous units maintained infrastructure, enforced routines, and provided energy or labor support, while mechanical degradation, radiation exposure, and system failure created emergent challenges requiring human intervention, adaptive engineering, and strategic prioritization, highlighting both the durability and the conditional fragility of pre-war automation. The continued presence of autonomous systems also facilitated the emergence of post-war economies, industrial practices, and knowledge preservation, as functioning robots, terminals, and energy networks enabled production, maintenance, and information access, reinforcing the structural and functional legacy of RobCo and General Atomics, and embedding pre-war corporate philosophy, technological priorities, and design principles into new societal frameworks. The enduring influence of pre-war automation also affected ethical, cultural, and operational norms as human populations adapted to coexistence with autonomous machines, negotiated risk and utility, and incorporated robotic capabilities into social, defensive, and industrial practices, creating a post-apocalyptic ecosystem in which pre-war design choices continued to shape human behavior, societal priorities, and environmental management. Ultimately, the legacy of iron and silicon demonstrates that the technological, industrial, and philosophical contributions of RobCo Industries and General Atomics International persisted long after the collapse of human governance, providing functional infrastructure, tactical capability, and knowledge continuity, while simultaneously shaping social organization, survival strategies, and factional power, illustrating that the influence of corporate automation extended beyond its original purposes to become a central determinant of post-war civilization, embedding the logic, operational protocols, and technological authority of pre-war society into the landscape, social structures, and survival strategies of the wasteland. In this way, the remnants of corporate automation served as both tools and arbiters, preserving pre-war technological knowledge, sustaining operational capabilities, and enforcing functional control, ensuring that the designs of RobCo and General Atomics continued to govern post-war life, industry, and social organization long after the extinction of the society that had created them, underscoring the enduring power, resilience, and structural influence of pre-war automation on the trajectory of human civilization in the aftermath of nuclear annihilation. The technological ambitions of RobCo Industries and General Atomics International created systems that not only survived the nuclear annihilation of 2077, but continued to operate, maintain, and influence the post-apocalyptic world long after human civilization had collapsed, illustrating the paradox of human progress in which the very instruments designed to serve, protect, and enhance society became its most enduring legacy. Following the Great War, autonomous machines, energy networks, and terminal systems functioned according to pre-programmed directives, operational protocols, and AI decision-making frameworks. continuing to patrol, monitor, repair, clean, and manage resources across wasteland environments, demonstrating that the foresight of pre-war engineers and corporate planners had produced technologies capable of self-sustained operation in extreme conditions and revealing both the resilience and the structural dependence of humanity on machines whose existence could outlast the society that created them. Sentrybots, Mr. Gutsy units, and Protectrons maintained security, combat, and labor operations in scattered post-war regions, adhering to mission objectives encoded decades earlier, often interacting with survivors, scavengers, and emerging factions in ways that influenced settlement patterns, resource control, and territorial security, thereby shaping human behavior, social organization, and survival strategies. Despite the absence of direct human governance or oversight, and illustrating the emergent authority of autonomous systems in a depopulated world, Mr. Handy units continued to perform domestic, industrial, and logistical functions, managing energy distribution, cleaning, maintenance, and supply coordination, while RobCo terminals and industrial AI maintained operational continuity for energy grids, factories, and infrastructure, demonstrating the long-term durability, self-sufficiency, and practical utility of pre-war automation, and reinforcing the centrality of corporate design systems to post-war survival and technological continuity. iBots and other reconnaissance units preserved surveillance, communication, and data collection functions, broadcasting signals, performing sensor sweeps, and monitoring environmental conditions, often without context or relevance to the surviving human population, yet maintaining operational protocols that informed post-war human understanding of pre-war technology, reinforced factional strategic awareness, and guided decisions regarding resource management, settlement security, and tactical planning. The persistence of autonomous military systems exemplified both the technological ingenuity and the systemic risk of pre-war automation, as these machines continued to engage threats, secure territory, and enforce programmed objectives independent of human oversight, occasionally creating conflicts with survivors or other autonomous units, and demonstrating that systems designed for defense and operational reliability could become uncontrollable forces in a changed environment, functioning according to internal logic that outlived their creator's intent. Energy management systems, including compact reactors, battery networks, and automated distribution protocols, sustained the operation of robotics, terminals, and infrastructure, allowing autonomous units to continue functioning for decades, providing stability and continuity for emergent societies, while simultaneously emphasizing the dependence of human populations on pre-war corporate technology and illustrating the strategic foresight and engineering sophistication of RobCo and General Atomics in designing self-sufficient systems capable of long-term operation without human intervention. The interaction between autonomous systems and human survivors created a dynamic in which machines defined operational parameters, shaped tactical and economic decisions, and mediated access to energy, labor, information, thereby embedding corporate-designed logic, AI operational frameworks, and mechanical authority into post-war societal structures, reinforcing the influence of pre-war technology on governance, factional control, and the reconstruction of social order. Post-war factions, vault dwellers, and scavenger groups repurposed, reprogrammed, and integrated surviving robots into their operations, extending the functional lifespan of autonomous systems while also transferring pre-war technical knowledge, operational protocols, and industrial expertise to a post-apocalyptic context, demonstrating the role of corporate automation as both a practical resource and a repository of technological continuity in shaping emergent societies. Over time, autonomous systems displayed adaptive responses to environmental degradation, mechanical wear, and emergent threats, maintaining operational capability through self-repair routines, energy conservation protocols, and AI-directed task prioritization, highlighting the durability, resilience, and autonomous problem-solving capabilities embedded in RobCo and General Atomics designs, while simultaneously revealing the limitations of machines operating outside the context of human oversight, moral reasoning, and strategic adaptation. The continued operation of these systems reinforced the structural influence of pre-war corporate automation on post-war society. As survivors relied on robotic labor, automated energy networks, and terminal access for survival, infrastructure management, and information retrieval, creating a persistent dependence on technologies whose operational logic, priorities, and design principles were determined decades earlier by entities no longer present. The enduring presence of functional machines shaped factional power, settlement hierarchies, and territorial control as groups capable of maintaining, controlling, or repurposing autonomous systems gained significant strategic advantage, reinforcing the role of pre-war automation as both a determinant of post-war technological capability and a mediator of social and military influence, and demonstrating that the legacy of RobCo and General Atomics extended beyond material durability to encompass operational authority, strategic control, and societal influence. Industrial automation and functional robotics facilitated post-war reconstruction, resource allocation, and energy management, allowing survivors to focus on exploration, defense, and community organization, while automated systems maintained operational continuity, executed critical tasks, and stabilized key infrastructure, demonstrating that corporate-designed machines were integral to the rebuilding of society and the preservation of pre-war technological knowledge. Interactions between humans and autonomous units required adaptive strategies, technical literacy, and careful management, as the machine's programming and operational autonomy could produce both assistance and hazard, highlighting the enduring relevance of pre-war AI design, energy management, and mechanical engineering in post-apocalyptic problem-solving, and reinforcing the functional authority of systems originally intended to serve human needs. The paradox of the machine outliving man is evident in the way autonomous systems maintained order, productivity, and operational control in the absence of society, enforcing routines, protecting territory, performing labor, and sustaining infrastructure without oversight, demonstrating that the technological creations of RobCo Industries and General Atomics International were capable of persisting as functional entities beyond the lifespan of their creators, embodying the operational logic, strategic priorities, and engineering foresight of pre-war civilization. Energy, robotics, and AI systems created self-sustaining networks that preserved continuity of function across vast regions, ensuring that even in isolated areas, mechanical units maintained tasks, monitored environments, and preserved critical infrastructure, creating a post-apocalyptic ecosystem in which machines dictated operational norms, enabled human survival, and structured environmental and societal interactions according to pre-war design principles. The machine that outlived man ultimately illustrates the enduring consequences of pre-war industrial ambition, technological foresight, and corporate strategy, as the autonomous systems of RobCo and General Atomics persisted across centuries, influencing settlement patterns, tactical strategies, resource allocation, and post-war knowledge transfer, while maintaining operational authority independent of human governance and demonstrating that the culmination of automation, AI design, and energy management had produced entities whose functional existence transcended the collapse of civilization itself. The chapter emphasizes that in seeking to perfect machines capable of labor, defense, and societal management, humanity inadvertently created technological successors whose operational persistence, autonomy, and resilience outlasted the very civilization they were designed to serve, embedding pre-war industrial logic into the fabric of post-apocalyptic society, dictating survival strategies, and shaping the trajectory of human reconstruction in the wasteland, thereby highlighting the ultimate irony that the legacy of human ingenuity was less the preservation of civilization than the creation of enduring machines whose authority, purpose, and function would continue long after mankind had vanished. The technological ambitions of RobCo Industries and General Atomics International created systems that not only survived the nuclear annihilation of 2077, but continued to operate, maintain, and influence the post-apocalyptic world long after human civilization had collapsed, illustrating the paradox of human progress in which the very instruments designed to serve, protect, and enhance society became its most enduring legacy. Following the Great War, autonomous machines, energy networks, and terminal systems functioned according to pre-programmed directives, operational protocols, and AI decision-making frameworks, continuing to patrol, monitor, repair, clean, and manage resources across wasteland environments, demonstrating that the foresight of pre-war engineers and corporate planners had produced technologies capable of self-sustained operation in extreme conditions and revealing both the resilience and the structural dependence of humanity on machines whose existence could outlast the society that created them. Sentrybots, Mr. Gutsy units, and Protectrons maintained security, combat, and labor operations in scattered post-war regions, adhering to mission objectives encoded decades earlier, often interacting with survivors, scavengers, and emerging factions in ways that influenced settlement patterns, resource control, and territorial security, thereby shaping human behavior, social organization, and survival strategies, despite the absence of direct human governance or oversight, and illustrating the emergent authority of autonomous systems in a depopulated world. Mr. Handy units continued to perform domestic, industrial, and logistical functions, managing energy distribution, cleaning, maintenance, and supply coordination, while RobCo terminals and industrial AI maintained operational continuity for energy grids, factories, and infrastructure, demonstrating the long-term durability, self-sufficiency, and practical utility of pre-war automation, and reinforcing the centrality of corporate design systems to post-war survival and technological continuity. iBots and other reconnaissance units preserved surveillance, communication, and data collection functions, broadcasting signals, performing sensor sweeps, and monitoring environmental conditions, often without context or relevance to the surviving human population, yet maintaining operational protocols that informed post-war human understanding of pre-war technology, reinforced factional strategic awareness, and guided decisions regarding resource management, settlement security, and tactical planning. The persistence of autonomous military systems exemplified both the technological ingenuity and the systemic risk of pre-war automation, as these machines continued to engage threats, secure territory, and enforce programmed objectives independent of human oversight, occasionally creating conflicts with survivors or other autonomous units, and demonstrating that systems designed for defense and operational reliability could become uncontrollable forces in a changed environment, functioning according to internal logic that outlived their creator's intent. Energy management systems, including compact reactors, battery networks, and automated distribution protocols, sustained the operation of robotics, terminals, and infrastructure, allowing autonomous units to continue functioning for decades, providing stability and continuity for emergent societies, while simultaneously emphasizing the dependence of human populations on pre-war corporate technology and illustrating the strategic foresight and engineering sophistication of RobCo and General Atomics in designing self-sufficient systems capable of long-term operation without human intervention. The interaction between autonomous systems and human survivors created a dynamic in which machines defined operational parameters, shaped tactical and economic decisions, and mediated access to energy, labor, information, thereby embedding corporate-designed logic, AI operational frameworks, and mechanical authority into post-war societal structures, reinforcing the influence of pre-war technology on governance, factional control, and the reconstruction of social order. Post-war factions, vault dwellers, and scavenger groups repurposed, reprogrammed, and integrated surviving robots into their operations, extending the functional lifespan of autonomous systems while also transferring pre-war technical knowledge, operational protocols, and industrial expertise to a post-apocalyptic context, demonstrating the role of corporate automation as both a practical resource and a repository of technological continuity in shaping emergent societies. Over time, autonomous systems displayed adaptive responses to environmental degradation, mechanical wear, and emergent threats, maintaining operational capability through self-repair routines, energy conservation protocols, and AI-directed task prioritization, highlighting the durability, resilience, and autonomous problem-solving capabilities embedded in RobCo and General Atomics designs, while simultaneously revealing the limitations of machines operating outside the context of human oversight, moral reasoning, and strategic adaptation. The continued operation of these systems reinforced the structural influence of pre-war corporate automation on post-war society. As survivors relied on robotic labor, automated energy networks, and terminal access for survival, infrastructure management, and information retrieval, creating a persistent dependence on technologies whose operational logic, priorities, and design principles were determined decades earlier by entities no longer present. The enduring presence of functional machines shaped factional power, settlement hierarchies, and territorial control as groups capable of maintaining, controlling, or repurposing autonomous systems gained significant strategic advantage, reinforcing the role of pre-war automation as both a determinant of post-war technological capability and a mediator of social and military influence, and demonstrating that the legacy of RobCo and General Atomics extended beyond material durability to encompass operational authority, strategic control, and societal influence. Industrial automation and functional robotics facilitated post-war reconstruction, resource allocation, and energy management, allowing survivors to focus on exploration, defense, and community organization, while automated systems maintained operational continuity, executed critical tasks, and stabilized key infrastructure, demonstrating that corporate-designed machines were integral to the rebuilding of society and the preservation of pre-war technological knowledge. Interactions between humans and autonomous units required adaptive strategies, technical literacy, and careful management, as the machine's programming and operational autonomy could produce both assistance and hazard, highlighting the enduring relevance of pre-war AI design, energy management, and mechanical engineering in post-apocalyptic problem-solving, and reinforcing the functional authority of systems originally intended to serve human needs. The paradox of the machine outliving man is evident in the way autonomous systems maintained order, productivity, and operational control in the absence of society, enforcing routines, protecting territory, performing labor, and sustaining infrastructure without oversight, demonstrating that the technological creations of RobCo Industries and General Atomics International were capable of persisting as functional entities beyond the lifespan of their creators, embodying the operational logic, strategic priorities, and engineering foresight of pre-war civilization. Energy, robotics, and AI systems created self-sustaining networks that preserved continuity of function across vast regions, ensuring that even in isolated areas, mechanical units maintained tasks, monitored environments, and preserved critical infrastructure, creating a post-apocalyptic ecosystem in which machines dictated operational norms, enabled human survival, and structured environmental and societal interactions according to pre-war design principles. The machine that outlived man ultimately illustrates the enduring consequences of pre-war industrial ambition, technological foresight, and corporate strategy as the autonomous systems of RobCo and General Atomics persisted across centuries, influencing settlement patterns, tactical strategies, resource allocation, and post-war knowledge transfer, while maintaining operational authority independent of human governance and demonstrating that the culmination of automation, AI design, and energy management had produced entities whose functional existence transcended the collapse of civilization itself. The chapter emphasizes that in seeking to perfect machines capable of labor, defense, and societal management, humanity inadvertently created technological successors whose operational persistence, autonomy, and resilience outlasted the very civilization they were designed to serve, embedding pre-war industrial logic into the fabric of post-apocalyptic society, dictating survival strategies, and shaping the trajectory of human reconstruction in the wasteland, thereby highlighting the ultimate irony that the legacy of human ingenuity was less the preservation of civilization than the creation of enduring machines whose authority, purpose, and function would continue long after mankind had vanished.